And we're back. It is a Monday, and it's COMP392, and it's the winter 2016 semester, week 3, sorry, lesson 3, part 1. And I want to talk about a couple of administrative issues first thing off, and then get right into actually using some of this stuff we've been talking about for the last couple weeks. So let me pull up a couple of things to note. 3JS has been updated. I don't know if you guys have figured that out, but if I go to 3JS for GitHub, right? If I go GitHub 3JS, and I think it's Mr. Doob 3JS is what it is, right? That's his kind of site. This is where you get all the builds and everything else for 3JS, the actual GitHub repository. We haven't actually been here. We've talked about it. We've got it through Bower, but what if you want to get it by hand, right? So this is where you get it from. And if you actually look at 3JS, the actual under build, so I went to, again, github.com/Mr. Doob, MRD0DOOB, 3JS, 3.js, and then it says tree/master/build. If I go there and if I take a look at the 3JS library, and I'll go back in a second to show you how I got there, for those people who can't get there, one day when it's still cycling. Notice how the revision number is 73, right? 73. Our last revision was 71, the one I did like when I first made the template, 71. So it's revised twice. And that means what's happened is if you download it, just FYI, if you download this thing and start it again, right? Like if you were to start a new template from scratch right now, what could possibly happen? There might be some breaking changes is the answer, right? So be careful, and especially with with JavaScript, this happens a lot. You download a JavaScript library and it's a version, let's say, like we did before, 7.1, and now it's version 7.3. And then also the TypeScript files have also updated, right? So the latest versions, I believe, are also 7.3 or 7.4 or something like that. So if you're using an old TypeScript file, it may not be able to detect some of the new features that are in 7.3. Okay, just FYI. And that's what happens with, like I said, this one, Create.js. If you're doing AngularJS, if you're looking at jQuery, no matter what kind of library is out there, they kind of update fairly frequently. And we're kind of living on the bleeding edge here because we're doing 3D stuff. So expect that things are going to change. Okay, just FYI. All right, so that's what's kind of happening with this, right? So how do I make a correction? Well, I've been starting to make corrections in the last lesson, which we haven't got to yet. But if I go to my GitHub, and this is where I'm going to start with today. I'm going to start with this as a template, and then we'll talk about it afterwards. If you go to github.com/Centennial College, and you look at not 4, I'm still working on 4 to present to you for next day, but lesson 2, part 3, right? Lesson 2, part 3. If we can look at that one, I have updated both the scripts file, right? And what I'm going to do with this one is I'm going to take away the contingencies. Let me just go to core for a second. The kind of the dependencies that I have for under the .gitignore file, so that it doesn't put up the latest version, and I'll just put up the latest version for you. So in other words, instead of you having to go and download and go to Bower and get the latest one, I've got it done for you. So how do you get it? If you're going to update your version, how do you update the version of the library that you're using? Well, there's a couple ways. One, through Bower. That's the first way I would do it. So if I was going to look at a version that I already had up, I would do kind of a Bower install, whatever the library is, 3JS, right? And then --safe again. And what's going to happen is it's going to go out there, get the latest version, and slap it in. And it'll also ask you sometimes, which version do you want? Same thing with TSD. If you go TSD install, and then 3JS as an example, it'll go out and grab the latest version and put it in. Now remember, these, if you keep stepping through the latest versions, guys and girls, there's a lot of experiments that this guy does, right? Like things that are experimental, like I might have a function or something, and it might break your build. So if you don't want that to happen, the safest thing is if it's working, keep it where it was, right? Maintain the latest version of what it is. But if you want to get to the latest build, you can certainly start with COMP392 lesson 2 part 3 as our template. and this is what I'm going to start with today. So we all have the latest builds. I have to do a couple things for us to get there, though. So how am I going to do that? I'm going to go into. I'm going to show you this. I have, of course, my own files, right, that I keep track of everything, and you should too. If you're a developer, you should keep track of the way things go for you. So I've got them under. I'm just going to go into part 3. Here's part 3, or part 4. Part 4. And under part 4, now I'm going to open up my Visual Studio Code for a second and close down this version here. Just a second. Bear with me while I show you what I'm talking about, and then you'll get right into. You'll understand when I get in there. So I'm launching my COMP392, and I'm looking at, let's say, part 4 for the example. I'm going to pass it into Visual Studio Code, and so this is part 4. We'll talk about this one. And it's significantly different than the book. And then the reason for that is because some of the functions in the book no longer exist in 3JS. Example would be there is a compute centroids function that's gone. They've taken it out, actually, revision 67. We're at revision 74 or 73 or whatever it was. So it's been several revisions that it's gone. Why? But the book just came out in 2015, you might ask. And the answer is, yeah, it did come out in 2015, but in 2015, they removed those things, right? So that's what happens when you have a book. The book, and that's not just for this course, for 3JS. It's the same for CreateJS. It's the same for AngularJS. It's the same thing for all these things. The book may be a little bit behind because it was published. It took time to publish it. By the time it was published, you know, you're several revisions behind. If you downloaded the book examples, though, they would work because it's using the previous version of the library, right? But that library doesn't exist, so why would we talk about it? It's been removed. Why would I talk about a function that's been gone? It's been taken out. So I'm not going to talk about computing centroids. If you see compute centroids as one of the problems you have in a function, there might be some other things that it's asking you to do. It won't work properly, so I've had to rework the code, and that's why it's taken me so long to come up with lesson 2, part 1, 2, 3, because I've had to go through it, check it to make sure it works for all you guys, and it does. Apply TypeScript to it, because I've had to pass through with TypeScript so I can show you the TypeScript version of your code, and then show you the working version. So this version is the one we're going to use, and I'm going to update it here on GitHub in a second. The way I would put everything up online, and again, this is the preferred version. If I actually was sharing these files with somebody else, right, as an example, in a development-like environment, like production, I would never include my typings on GitHub, nor would I ever include my scripts, because that means I'm getting you to download the library again every single time. It's almost like a self-contained project. I would never get you to do that. I'll always get you to use Bower and all this other stuff, this front-end dependency manager, to download only the libraries that you need because they're there. Why would I get you to, to get all that stuff again and again? But in our case, because things are moving so quickly with 3JS, it seems, makes sense, right? So I'm going to take these two things out of my gitignore file. Remember, my gitignore file, what it does is it says to Git, don't upload anything to do with node modules, scripts lib, typings, Bower components. Ignore all those things. I don't want to ignore these two things. So I'm going to take that out. And when I do that and save, what ends up happening is now I have 99 updates, right? 99 plus updates, because there's a lot of little files that come with the libraries. And that's what I wanted to avoid. I don't want you to download 100 plus files every time you had a repository. I wanted you to download only the files you need. But unfortunately, things are as they are. I have to do what I have to do. So let's go into here. I'm going to notice all these changes. I'm going to stage everything. Here they all are. And then I'm going to say updated gitignore file, right? So that way everything is included. And then, so these are more, there's more of my files are being tracked now up on GitHub than they were before. So push. So now when I do this, just to show you how this is done, I was waiting for me to do this today, like to myself, so that way when I saw you guys, you would see the change. If I refresh, you're going to say, did I refresh the right one? I need part 4. Part 4, which, did I do the right one? Did I want to do the right one? Did I want to do part 4? That's the question. Watch, I messed up, right? Oh, yeah. Yeah, part 4 is the one. So if I go to part 4, notice how it says, updated my gitignore file. Why? Because the typings and scripts came in there, see? typings and scripts weren't even up there before, right? And now they are under my lib folder. You'll see all the scripts you need for 3JS and the other libraries. So please download COMP392 Lesson 2 Part 4 so we're on the same page. And then what I'm going to do is I'm going to wipe out everything. First, I'm going to show you what it looks like. I'm going to wipe out everything, and then I'm going to also show you how to start a new file if you were to fork me or clone me on the desktop, right? So, and even if you wanted to start your own file, let's say, for example, this is you, not me. This is not Centennial College. It's not Tom. It's you, and you have a project you want to use that as your springboard to get to the next, almost like a template to start your project, your assignment number 1. How would I do that, right? Well, I would download this project, right? And let's say, for example, I wanted this to be my boilerplate now because my boilerplate is old. Remember the boilerplate I had up? What's my boilerplate? Let's take a look. So if I was going to go to Centennial College, remember I had that I told you that this was going to be a moving target, this 3JS boilerplate. Let's see if I can find this. It'll say COMP392. And if I look through there, you'll see that there's several different lessons I have up there. But one of the ones we want to kind of put up here is kind of a 3JS boilerplate. And if I do like 3JS boilerplate, there's 2. I have one for Visual Studio that we made, right? And there's a demo for Visual Studio. And there's also a 3JS boilerplate on its own 14 days ago. I'm going to make a new one that I'm going to call COMP392 3JS boilerplate, just so that way you guys have the most recent one, and we'll be using that. Eventually, I'll get rid of some of these, right? The new one I'm going to make, yeah, and that's why I'm making it with you guys today. And we'll bounce from there, all right? So let's do this thing. Let's see. So I'll explain to you what I'm doing. Okay, so how do I do it? First of all, let's go back to what I was looking for. So I was looking at this repository, this COMP392 Lesson 2 Part 4. So you can create it with me. I would recommend you download this one, and I'm going to do it too, just as if like I didn't have it. All right, so here I am. I'm going to click Download Zip. So I'm at Centennial College, COMP392, Lesson 2, Part 4. And I'm going to download the zip file. And when I do that, I want to put it on my desktop. Okay, there it is. So it's on my desktop. And I want to unzip it right away. Okay, cool. So let's take a look at my desktop now and see what I've got. So it's over here. Okay. And I got a messy desktop, but don't worry. Okay, so then here's my COMP392 Lesson 2, Part 4. And notice that the actual folder itself says COMP392, whatever the thing is, right? My recommendation is you rename this thing completely into COMP392 3JS boilerplate, right? Now, if you're using Visual Studio, what you need to do is you need to launch Visual Studio and drag and drop the contents of this inner folder into your new project. You can't just launch this project. It won't work properly. You have to make a new almost like container project, and you may want to call it what I'm telling you to call it, which is going to be COMP392, and we'll say 3JS boilerplate. That's what I'm going to name it, 3JS boilerplate. There it is. So you probably want to call your project this, and then drag this stuff into your project. So if you actually go into the folders, grab all this content here, scripts, the typings, everything, and drag all this stuff into your Visual Studio 2013 or 2015 project. It'll work just like this. And that's my recommendation. Now there's other ways to do it too, but that's probably the easiest way to do it. Okay, so I've got this project. It's called 3JS boilerplate, but I may or may not have a Git repository associated with it. So just as a recap, how to do this, I'm going to put this now into Visual Studio Code to make it easy. So I'm just going to put it over here, launch Visual Studio Code, make sure I'm on the file section, take my new folder that I just downloaded, drag it into this piece here over here. And now I have the latest files. Notice that if I click on this Git icon, it says initialize Git repository because there isn't a Git repository there anymore. When you download from GitHub, it doesn't include a Git repository link, right? You have to make your own again, which is good. Otherwise, you'd be linking to me, which is bad, right? Okay, so let's do this. Now, I know some people have been having some trouble here at school with using the initialize button. So if you click initialize, some people have a problem. When they click onto it, it doesn't do anything. And the reason why it doesn't do anything is for a couple of reasons. One, it's using HTTPS, right? And it uses Git in a weird way, right? And the school, for whatever reason, blocks any HTTPS through Git. And that's why we did that whole workaround with Git. So my recommendation is don't do it through here for now when you initialize, or push for the first time, do it through command line. But we want to kind of link our command line, which is pointing in the wrong position, to this project. And the way to do that here with Visual Studio Code is to right-click and go Open in Terminal, which is going to bring up my terminal in the right folder. Okay, cool. So now that I've got my terminal, what's the command to initialize a Git repository? You need to know these things because it's probably something I might ask you, right? So git init, right, is the first the command on the console to initialize a Git repository. Git init, right? And what it does, it says, hey, take the Git program, the application in my console, and initialize it. Git init. Okay, cool. Now, I could do things like add everything, git add, but there's a couple of changes I want to make first before I add for the first time. For example, my README file. It says listen to part 4. That's not right. It should be, we should rename it, right? We should kind of talk about what this README file is for. So it's COMP392, and it's going to be the 3JS boilerplate, 3JS boilerplate, right? So that's going to have to change. So before we add this in to our changes, let's change this stuff, right? So it's just and we'll do this, advanced graphics at Stadium College. Okay, cool. So we've changed our boilerplate. That's one. So I'll save that one. Now, there's some other ones. We'll go into the next piece. Bower.json also has the wrong name. So let's make sure that that is the right name. So keep it lowercase. And my recommendation is in the Bower.json, there's a couple things you can do here. I could rename it here in Bower.json, or probably a better idea, because we're going to set up a Git repository later on, is do this after, right? While we're setting up the Git repository. But for now, because we want to change this too, look at my Git repository points to the wrong place. It points to me, which is wrong, right? You want your home page to point to the Git repository at the very minimum, right? So let's rename it up here, right? So we'll call this COMP392, and we'll say dash, and all in lowercase, 3JS, right? A boilerplate, right? And save. And now in here, what we want to do is we actually want to copy paste, right? So we want to say and because it's just a description for advanced graphics. So that's the second thing we changed. We changed our Bower.json file. I'm changing these because they've got to reflect. If this is our boilerplate, they've got to reflect all of our changes. You can't say lesson 2, right? It's got to say the right thing. Same thing with index.html. In index.html, it says lesson 2 code for part 4, right? So we're going to change this to what it's supposed to be, which is COMP392 3JS boilerplate. All right, so those 3 places. Index, I changed my my Bower, and I changed my README file. And I'm going to say press save. So now I've got extra changes that I haven't added into Git yet, and that's why I did it first. I changed them first, and now I'm going to add everything into Git as one big commit for the first time, my initial commit. And there's probably other stuff in here that we have to change, but for now, this is okay. So I'm going to go back to command line here just to show you how this works, and I'm going to go git add dot. Remember, the dot represents all the files in the project folder and all the recursive folders underneath that. So I'm adding everything to my repository that I haven't specified to ignore in my git ignore file. If I've told git ignore to ignore some stuff, it'll ignore it, but the rest will all be tracked. And what I want to track is pretty much everything here. Because remember, I'm using this as a boilerplate for you guys, and I'm going to press enter. So 2 seconds, it adds everything in, and then once we've got our everything staged, what's the next step? We've initialized the repository. We've done the git add dot, which kind of stages everything. What's the next step? Part 2 or part 3, number 3. A commit, right? So we need to name our commits. We're going to say git commit minus M. It's all on the command line. M stands for message, and we're going to put a friendly message to tell GitHub and GitHub users what we're doing here. What's our commit mean? It's going to be our initial commit for this repository, and we're going to press enter. And you're going to see a bunch of these. It'll look different for you guys on Windows users. Even when you put git add dot, it probably added all kinds of other stuff there. But what this basically says is these are all the things we're adding in, these 99 plus changes. Okay, cool. So we've added it into GitHub. We've done this all kinds of practice last week, so you guys have seen this more than one time. That's why I'm moving a little faster today. We've added this all into GitHub, or into Git, I mean. But we haven't connected to GitHub yet, and the way, of course, to do that is to actually create a remote, right? So I'm going to go GitHub, And I'm going to go plus, new repository, and I'm going to create a new one for Centennial College called that name that we just made, COMP392, and we'll say 3JS boilerplate. Okay, so that's what it's going to be called. So you can always look here, and this is the one that I want you guys to base all of your assignments on for now, right? And then we'll update it as we go, hopefully. Okay, cool. So this is it, and I'm going to click Create Repository. When I do that, it gives me a container where my local Git repo is going to be pushed to, and I need to get this other line here, this Git remote add line. Now you can type it by yourself, or you can just do what I'm doing the lazy way, which is copy and paste. Or you can use the online tool, the app that comes with GitHub. Or there's also an app that you can download from Bitbucket that also works. There's a bunch of different apps. You can download stuff from the App Store. If you're a Linux user, you can download stuff from their stores, and so on. There's tons of stuff to do that kind of connects you to Git. Okay, one more command. I want to push, right? So git push -u for unconditional, and then origin master. And then what this is going to do is take my local files, and I've already pointed it to GitHub with my git remote add. I'm going to throw my files up on GitHub, and now that I'm successful, and you might have to log in to do this and put your password. Unless you set that up, you can fix that by Googling it. How do I add in? So how do I add a thing to not have my username and password come up all the time, kind of thing? I've got this boilerplate up now. That is the version that I'll be working with. So if you were just watching this whole time, maybe you're even smarter, right? Because you can always just download this now, and it's ready to go. But you're still going to have to do something if you want to add this into your new file. So wherever I start a new file with us together, I'll be starting with this, right? Because this is kind of works, you know, and everything else. And I'll explain what I've been doing here because there's some stuff I've been doing behind the scenes for some of these examples that I've already kind of gone ahead and created some additional folders in the background. An example of that, if I click in my scripts folder here up on GitHub, you'll notice that scripts has core, which is I've kind of compartmentalized my game.ts in a core folder. I have lib, where all my lib libraries are, right? And I also have objects. And under objects, I have a couple of them that I've kind of put together. One of them is this control object that I keep changing every example, this little control object that I made. And I have another one called game object, which that means I can kind of add in any regular geometry, like for example a cube, a sphere, or whatever, really quickly. I've done that one, and then I've also kind of got this new one called point. This little point class that I have just for illustration purposes, not really necessary, but I kind of put it together so that way you can see how to put together a little class in TypeScript as an example. And what this does is a container. It actually is a little point class that has X, Y, and Z as points. By the way, 3JS has something like that that's even more advanced called vector3, right? But we're not going to use vector3 in this example. We're going to use point. Okay, so let's take a look at how this relates to what we're doing on here in Visual Studio Code. All right, so I've got my boilerplate. Can I start working from this one, or am I going to call it something else? Like, for example, you know, my lesson example that I was going to work with. Like, I wouldn't start with this one. This is my boilerplate. If I start changing this one and updating GitHub, that means my boilerplate's going to change, and then you're going to start with that one next time, right? So that doesn't make any sense. I want to make a copy of this one. I want to make a copy of my boilerplate so I can use that and rename that afterwards, because I just did this already. I'll do it one more time so you can see it, and then I'll set up another repository for today, which we're going to call COMP392 Lesson 3 Demo, right? Which we're going to use for our demoing class. It'll be based off this boilerplate, right? But it won't be this boilerplate. So you're going to see all this stuff again. Let's see how it goes. And again, this is all setup stuff, right? So how do I do that? So again, I'm just going to minimize everything and close this one off. And now that I have my boilerplate in the exact position that I want it, which is this, right? And I can download it from online, but I want to use the one I have. We'll do it the other way around now. Let's suppose you've already done this and you created it with me just now. How do I use this to create another one? How do I create another project from this one? Well, I could copy, and on the Mac you can duplicate, right? You can also copy and paste and rename it to something else. So on the Mac, it's as simple as just duplicating. And when I duplicate, it creates another one that says copy on the end. And Windows has a very similar function where you can duplicate or copy your files. Okay, cool. Both of them point to the exact same repository online. I got to fix that because this one's going to be a new one. I'm going to call this one, COMP392, it's going to be lesson 3 demo, right? That's the one I want to do. It's the demo we're going to be using for today and maybe for next day. So that way we can learn a little bit more about 3JS and be more hands-on, right? So, okay, how do I do that? So I'm going to go back to Visual Studio Code. Let me bring that up. There it is. Here's Visual Studio Code. And I'm going to drag and drop this one over here now. And if you notice, now it says COMP392 Lesson 3 Demo. Good. Okay, now what I need to do is go back in here. It's inside my my tsconfig.json, sorry, my README file, and change this. Lesson. Look how I'm getting some stuff down. Lesson is lesson 3 demo, and we'll do the same thing here. So just go ahead and if you follow me, you can watch in this particular case, or you can do what I'm doing if you already kind of did it. So once I've done that, notice how I've got my GitHub pops up and says, hey, you got to change. Well, no, there isn't a change. This will be my initial commit for this project. So I need to kill GitHub in a second, or kill Git for a second, and I'll show you how to do that on the command line. In Windows, the easiest way to kill Git is to remove the hidden directory. So if you go to the hidden folder in Windows and you remove or delete the .git folder, that means you've killed all your changes and now you can reinitialize Git. That's the easiest way on Windows. On the Mac or on Linux, you have to remove the folders a little bit differently. Okay, so we've done this. I've got to change this COMP392 demo. I'm going to go back to my index.html and rename this index.html piece right there. There we go. On the Bower side, just in case, I'm going to rename it definitely over here and retype it over here because I want it all in lowercase, right? So lesson 3 demo, all lowercase. There we go. So I've done this, and again I can update my homepage later. So I've done these changes, right? But now I want to kill Git. So how do I do that? First, I want to kind of reveal my project in terminal. Let's try that again. I want to reveal my project in terminal, and it'll bring up terminal. So now it's looking at COMP392 Lesson 3 Demo. That's the one I want you guys to follow for today. And I want to go in there and say, remove, this on the Mac, minus RF, very dangerous. Don't do this on the Linux or Mac systems. If you do minus RF star, you'll kill everything, right? That means that your entire system is gone. So please don't do that. RM minus RF, and you have to mention that, not star. Mention that, don't put star in like this. Okay, and then put in the name of your folder, which is .git, right? So what this is going to do is going to go up here and say, we'll wipe out .git. Notice on the left-hand side here, it's gone, right? Like it's, you notice that there's no Git, right? Okay, now I got to reinitialize, and I'll do again the same way. So git init. We've made our changes. So git add dot. We'll say commit git commit minus m, and we'll say initial commit. Right, good. And now we want to connect it to a repository that doesn't exist, but which we'll make right now up on GitHub. So I'll go up here and click plus your repository, and you guys have seen this a ton of times. But hey, what the hell? We'll do it again. COMP392, and we'll call this lesson 3 demo, because that's the demo we're going to use. And this one you should download afterwards, because this is the one I'm going to be using. If you want to be with me, you'll be using this one to do our new stuff with. Okay, cool. I'm going to go here and paste and git push minus u origin master and clickety click. Barber trick, right? And we got, that's from the old Barber Papa show back in the day. Okay, no one knows what that is because you guys are way, way younger than I am. Okay, so let's take a look at this. We can see that here's our gitignore file, and this is for our lesson 3 demo. And this is the one that I'm going to be using because I won't corrupt or change this. I don't want to corrupt this. I want to keep this pristine. Right, I want to make sure this is what you can use. You can download this. You can fork this if you want, right, to use this in your own, whatever, right? But we don't want to change this one because this is our boilerplate. If we change our boilerplate, it's because we've recognized something needs to change. We need to go there and mess around with it and change it up. And yes, I could have gone there and removed a bunch of stuff that's already there, and then kind of made some very generic changes. And maybe in the future we will together. But for now, I'm just going to leave it as is. I'm going to go back here to our lesson 3 demo, and this is where I want you to look and see from now on. Again, if you wanted to create one for Visual Studio, you could certainly just download this zip file and drag and drop all these files into an empty project that you'd create through Visual Studio 2013 or 2015, and you'd be fine. Everything would work. Okay, so let's get to it. So we've got our new project now. We've got this test project, and just to make it more unique, what I'm going to do here on the command line, I'm going to clear on Windows machines is CLS, and if I clear, what I want to do is I want to run that Bower init one more time, and I'll show you why. So if I say Bower init, press enter, it's going to run through, and I'm kind of accepting stuff, and I want to see if it's going to change anything. Let's see. Notice how it says our lesson is COMP392 lesson 1 part 2. Well, that's not right, right? So that, I could type it by myself, or let's just X out of this. So I'll say Control C to stop the little wizard. What if, and this is just putting it out there for you, what if we wanted to get the link for this ourselves? What do I do, right? Well, I go up to GitHub, and this is our lesson 3 demo. Notice how this is the link for our lesson 3 demo. I'll copy this link. I'm going to go back into our homepage, and then I'll just paste it in there, right? So there it is. That's the actual link that we're using for this project. So that's the first change we've made. We've updated our homepage link. And if I wanted to be really a real stickler, and if I was going to be doing stuff with GitHub all the time, by the way, this is not a GitHub class, I swear. I go over here to changes, click on this thing, and say updated bower.json, right? Because that's what we just did. Click the check mark and go to here and push here inside the tool, and then it would push up to GitHub. And then if I go to GitHub now with our COMP392 lesson 3 demo and refresh, you'll see that that updated bower.json file is up right here, right? So that's pretty cool. All right, cool. So we've done everything to set us up. Let's get to it finally, right? So, so one thing to note is this. I'm going to be working in a file called, under the core folder in scripts, I'm working with a file called game.ts. Now again, the book's examples don't show game.ts or app.ts. They do it all in like an index.html file, and they embed their JavaScript for their examples, right? And someone asked last time, do I really need to do all these imports? The answer is no. You don't have to do any of these imports. I'm using these imports because I don't want to go 3.scene. I just want to say scene, right? So it's a little bit cleaner, right? But which means I got to do these aliases at the top, right? So I want to, so that way I don't have to say, 3.color. I just want to say color. I don't want to say 3.vector. I want to see just vector 3 and I'm good, right? So that's what I've done these for. You don't have to. Okay. These global variables, these are the global variables here in our scene. And notice I have a renderer, a camera, some stuff that we always have in our scene, right? Ambient light, a spotlight, controls, all kinds of stuff. One thing that I'm always changing the control. If you ever look at my examples, my control, the ones that appear in the top right corner of the screen, those controls with that GUI, they change, right? Okay. So let's look at our actual object. So I have something called an init function. Here's our init function. And in our init function, we have, I set up a couple things. I create a new scene. That's the first thing you need, right? Without a scene, the scene is a container. Hint, hint, I'm going to ask you this question. The scene is a container that contains everything else, right? Remember, we talked about this as almost like a display list that acts almost like an array. And every time I add stuff to the scene, by the way, this is exactly the same as it would be in Create.js if you're taking COMP397 for those people who have done it before, and for those people who are taking it now, then it's kind of the same thing. It's an array of display objects that I'm loading into the scene, okay, in order. So the scene is a container object that contains everything. My camera, it contains my my axis helper. It'll contain all my game objects, everything else I want. And I've called them game objects because eventually we're going to make a game. Even though we're doing 3JS, you don't have to call them game objects. They can just be called meshes for now because we're not playing any games yet, but we will. Okay, so and that's why I set it up that way. Okay, so we need to set up the renderer, which is the way we can render the scene, the type of renderer we're going to use. We're going to talk about that, and I always put that kind of at the bottom. So if I scroll all the way to the bottom of my file here, you'll see there's a section called Setup Renderer. A couple things to note is I'm creating an instance of a new renderer object. That's what I'm doing. And renderer, if I hover over it, it's part of the 3JS framework, and there's different options. You can render in WebGL. You can render in. You can create a canvas renderer. Here we haven't specified the kind of renderer, and we'll talk about what the default is another day. All right, so here I'm setting the clear background color to a specific color, as an example, and then I'm setting the size of the window. And I'm also, I've changed some stuff. Notice that in the old version of our code, remember I told you that 3JS updated, it says renderer .shadow map enable. And this is, instead of one shadow map enable, now they're asking us to do renderer .shadow map enable is equal to true. That's the new way of doing it. It's still backwards compatible with the old version. If you actually use the old version, it would work. It wouldn't break. But this is the new way we turn on shadow maps. Okay? So without this true, wouldn't render any shadows. Number one. Okay, cool. First. Second thing is we have this camera set up at the bottom here. And typically what we want to do, there's a couple of changes we can make. One is the viewing angle. So this is, like I said before, kind of the field of view. That's what this first piece represents if I hover over it, right? Our field of view is a number, and it's an optional number, right? And the other one is our aspect, like we talked about before. And if we wanted to make 640 by 480 or whatever, this is just going to take the camera, the window width of our browser, right? And this is kind of our near, the culling mask for how when we do not render stuff, how close it has to be, like 0.1 units away. And more than 1,000 units away, we're not going to render anything that far out because we won't be able to see it anyway. It's going to be too small. So anything beyond 1,000 units, we're not going to render it. A lot of times we cut that down. The higher the number, the more cycles it takes from our CPU to render those things. So more details, way back in the way 1,000 units away, lots of cycles to render. And we don't have a lot of stuff to render, so we can literally cut this down a lot if we wanted to. We'll leave it the same for now, but I'll show you what the difference is when we change this. Camera position is the actual position of our camera in three-dimensional space around the origin. So the origin being the 0, 0, 0 point in the middle of your screen, okay? And then camera lookout. There's a couple of options here we can use. I've created a new vector, vector 3, with a specific position for the camera, which is pretty close, 5, 0, 0. That's 5 units in the x coordinate, but 0 and 0 on the, that's where it's actually looking at in your origin. So the camera's positioned up, as an example, minus 20 on the x-axis. Remember that we're y up in 3JS, just like we are in Unity and in Maya and in 3D Studio Max. We're y up, not z up, right? That's a different way of doing it. Blender has z up, so it's kind of tricky that way if you ever looked at it, right? So because we're y up, that means 25 units up, right, along the y-axis, and then 20 units across the z-axis. That's what I mean. So x and z is the plane that we actually see. That's the xz plane, and the y goes up and down. So when you actually look at x and y with 3JS, it's x and then y to go up the screen, right? Which is kind of weird. Some people have problems with that orientation, but I'm just mentioning it so you know what it is. So that's where the camera's positioned, right? So, and then what it looks at. This is what it looks at. You can make it point to the origin if you want, right? 0, 0, 0. But this is what the camera looks at in this particular case. And then I use a little console command for each of these things to say, hey, by the way, just as a check, these things are set up. So if something doesn't go beyond these ones, I know there might have been a problem here somewhere. Chances are with these two functions, nothing ever happens. Okay, cool, like they always render. Okay, so that's one. So the camera renderer and the render and the camera and the scene. Notice I didn't put in anything like scene.add renderer, scene.add camera. I don't have to do that. They're already added in the background. They're not, those are the two things, they're two objects, if you will, that we don't add to the scene. It's inside the scene hierarchy. It's not there, right? They're there, but we don't actually see them as part of the scene. Okay, cool. Let's take a look at our axis helper. We're using our axis helper, which is the axis, And if I was to run this thing just to see what it is in our current form, I'm going to go to just down here. So let's take a look at what we've got so far. So I'm going to right click, and then I'm going to reveal in Finder or in Explorer on Windows systems. And then under here, here's my demo. I'm going to double click my index.html file. That's the easiest way to do it for now. Eventually it will fail, because that's why I've told you to use HTTP server. But if I double click, you can see that this is what you get. So this is the axis helper, this thing here. This axis helper is the thing that you're seeing. It's actually the axis to help us with where it is. So this is the y-axis going up, this green line here. This red line is the x-axis. And this blue line, and by the way, the red, blue, and green, they seem to be the same across all programs. They don't change that. I think that's the one thing I think that's consistent across all. It's like standard for those colors, right? So far, right? So if you see green, chances are it's a y-axis, even if it's another program, even if it's oriented differently, right? So there's the x-axis and the z-axis. So notice how we have our little object here. But that's the axis helper, this thing here. We have our plane, which is kind of big, right? Right now it kind of is this big. And we have our little control object on the right-hand side that we're using with the DAT GUI library, which is not a 3JS library. It's a Google library, actually. Okay, let's go back. So that's what this axis helper is. We're creating an axis helper. And in order for us to get the axis helper, how did I get this? It's actually included in the 3JS library. So if I go, axis helper is an alias. Here's our, somewhere in here, I've got an axis helper object, right, that I've aliased. Here it is. I've used the import statement to make an alias of this 3-axis helper class, as opposed to saying 3.axis helper. I know it sounds like, hey, you're only getting rid of 5 characters. Why did you bother, right? And you added all this, right? But trust me, in the end, you want to do this for things like Node.js. If you're doing anything with Node, Angular, anything like that, you want to do your these kind of aliases, because it presents a little cleaner when you're coding. Okay, so I've got my axis helper, and now because this is an object, I'm actually adding it to the scene, right? And it's going to add. Notice how there's an actual option here. If I hover over, it says, "What's the size of my axis helper?" And I've made it 20 units, right? So that's what it is, 20 units. You can make this smaller. Or however small you want, and typically it's not that big. It's usually half the size, like 10 units. So let's show you that. So if I say 10, and then if I transpile, so Command-Shift-B, Control-Shift-B on Windows machines, or if you're using Visual Studio, just save. I know it sounds easier, but actually it's better to do what I'm doing. Okay, cool. And then if I was to reveal it in Finder again or Explorer, go back to that folder and double-click, you'll see that it's shorter. Now, see the axis helper doesn't go the whole length of the plane. It's a lot smaller than it was before, right? So the axis helper is just there so we can know where our axes are, right? And by the way, this orientation of this plane here, not happy, right? Not happy with this orientation. I mean, how would I typically like it? Remember, I talked about this with Blender. You guys don't remember? Anyone remember how I like looking at my axis? Not like this. Right, here's the Y and here's the Z. Why would I want to look at it like this from this angle? Typically, I wouldn't want to look at the camera from this angle, right? And if I was to pull up Blender for a second, let me pull up Blender. And please forgive me when I do this, because don't be confused. Remember, Blender is a Z up. Right, here's my little manipulator, and they're the same colors, right? Z, Y, X. Now remember that's just the way Blender is. I wouldn't want to look at it like this. This is kind of how we're looking at it right now, right? I'd want to look at it like this, right? So that way I have my x-axis this way, and the other axis, in this particular case, our z-axis up and down. So I have to rotate my camera to be over here where I'm looking at it. And the easiest way for me to do that in the scene, right, if I have a proper orientation, right, if I want it to be like dead on like this, how would I move my camera over here in Blender? Anyone remember? Really quick way to do it. Which one? I could do numpad. There's a special way to do it, but if you go to View, and if I go to Line View, and if I align active camera to view, right, it's Control Alt Numpad 0, right? So if I click onto that, it shows me this. This is okay. I want to press the N button in Blender. and I want to lock my camera to view because this isn't obviously what I want to see. And I want to kind of pan out a little bit. And when I pan Blender now, my camera, this is panning the exact way I'm going to see my scene. Then I'm going to unclick my lock camera to view and zoom in. So this is what my scene is going to look like. It's not quite perfect. Let me just, there we go. It's a little better. There we go. All right, so that's how I've oriented my scene. So how do I get my camera from that? Well, if I click on my camera, you can notice how it has a location, right? And a rotation. Here it is right here. And a scale, right? Well, my location is 5 Blender units, 5.6 Blender units. Let's make it 6, so 0.6, just to make it even. So 0.6. And then my Y, this in Blender, is minus, let's say, minus 20.5. Right? It's my camera. And here's my my Z, which is, 15, let's say 16 units. 16 units even. So you see how my camera shifted around a little bit. My rotation is 52 degrees. That's kind of a weird, rotation on the x-axis. So that means across this red line. That's where my camera is. That's what, if you were going to visualize. Let's make it like an even 55 and press enter. Notice how it shifts everything down a little bit, right? And now this one, this on the y-axis, it's 0.656 something. Let's make it just 0.6. Nice and even numbers is what I'm saying, instead of like all those extra digits, right? And then on the Z, let's make it like approximately 1.1, 1.1. So almost exactly. If I wanted to make it exact, I can make it 1, whatever. So those are my values. So how do I take these values and apply them to 3JS? Because I've set up my camera where I want it, right? I've got it at a certain distance, right? Here's my location, which is position. So on the Y, remember we're Y up, I have to replace my Y is the Z, which means I have to transpose the Y and the Z values. So I have to change my X to 0.6. Let's do that. Let me go back here, and on my camera, and see if we can get this done. It's a little bit of some trickiness, but you're going to have to do this one time too. So notice how it's right now it's minus 20. I'm going to change this to 0.6. Let's see if it'll take it. 0.6. Okay, and my Y position on my Y position here is minus 20.5. That wouldn't be the Y. That would be the Z. So because remember it's minus 20.5 for the Z. There we go. And my Y is, my Z is actually my Y, so it's 16 units here. So that's what I have for my units, 16. So 0.6, 16 minus 20.5. And what I'm looking at, that's a different thing altogether. That's my angle, right? It's my angle. But I'm actually looking at, instead of 500, what am I looking at? My scene, right? My scene, like my 000. So if I could actually change that to 000 if I wanted to. That's my 000 point. I'm trying to look at the middle of my screen somewhere, right? So that's my angle. I don't have to really think about my angle too much, which is kind of cool here. So I can just aim it at a certain place and I get my angle automatically. Okay, cool. With these changes, I have to transpile. And let's see what I see now. If I see what I want to see and compare it to Blender, we may have to make some adjustments. All right, so go back here and refresh, right? And see, do I see the same thing as I saw before? Why does it take its sweet time? It should not. I said. Cookies, yeah, it might be. So that's why you're probably better off doing it in something like incognito window, right? So I'll open my incognito window up again, and I'll go back into that this view. Double click. Okay, that's not exactly what I wanted, but that's not bad. That's not bad for what I want. Take a look. Notice how here's the X and here's the Y. So I'm dead on actually. Right now, why does my plane look so big? Because it's massive. That's why my plane is huge, right? Let's make a plane on Blender to compare. So look at, here's my scene. Notice how it's dead on. I don't see the other side. I don't see this side. I don't see this side. So I'm trying to match up what I see here if I was going to do this, right? So I go back to this. And again, this might not be desirable to you. Also, my light is coming from this side, right? We have to change that around. So we have to change that to match what I see in Blender, right? Okay, cool. So, and I'm just using Blender as an example. So here's the X. And if you notice, here's the green line, which is the Y. And you can't see the Z because it's behind here. Z is way back here. It's in the same line as the X, as the Y. They're just on top of each other from this view, from this angle. Okay, so how do I modify this thing to be the same size? Let's go back. So I'm going to go back to Blender. And my plane is much smaller here. It's like if I was going to make it this size. First, let's add a plane. How do I add an object in Blender? Shift A. Right now, again, I have to add it at the origin. So I have to make sure that my cursor is at the origin if I want to be accurate. And notice how my three-dimensional cursor is right here. And by the way, to get this little panel, I press the M key, right? So I press Shift A. And I want to add a plane. Here it is. And I want to kind of translate this plane or make this plane as big as I can. I'm going to press the S key to scale this plane out a little bit. So it's going to look like this, approximately. So some part of it's going to be off screen, right? But the other part is going to be over here. So how do I do this? Well, notice how my scale is 8 times. That's one way of doing it. I can scale up 8 times, right? And my dimensions are 16 by 16 by 0, right? That's my dimensions. That might be the easiest way to do it. So I won't touch the scale, but I'll change my dimensions to 16, 16, 0. Let's see if I can do that. So go back here, and do I have a plane, first of all, right? So I've got my bunch of stuff here that we're going to get rid of in a second. But I've got my ambient light, I've got my camera, I've got my axis helper, and here's my plane, right? So, pretty huge, right? 60, 40, 1, 1. What does that mean? So it says it's a width, my height, and the number of segments, width segments, right? So one width segment, which is what I want. I don't want multiple width segments. I can cut my plane up a little bit more if I wanted to. And height segments, and those are optional, so I don't even have to even put them in, right? So width and height. So remember what we said, going back, my plane is 16 by 16, width and height. So let's change, that's why it's much smaller. So 16 by 16. Let's leave those the same, and let's leave the material the same for now. Now here's something that's bad. My X rotation on my plane it's rotated by half an angle, multiply my math.pi. What does that mean? What's that math.pi give us? Radians, right? That means it's slightly rotated, slightly off center. Let's just comment this out for now, right? So we can see that it's dead on, right? Okay, cool. So we've commented this out, and I'm going to transpile. And when I do that, when I go back to my scene, let's see if it's affecting the plane. And yeah, we're going to get this. We're just going to take this thing, and from now on, we're just going to put it inside of incognito window. We didn't have it up there anymore? No. So this is how. That's okay. I won't complain. Let's just do this. Now it's going to work. Okay, well, wow, what happened to our plane? How come it disappeared and it's gone, right? Like we said 16 units by 16 units, and it's like this big. But 16 by 16 isn't actual value, is it? Right? And the reason for that is because it's 8 times. I've scaled it up 8 times normal size, and a normal size for our plane is a 2 by 2 plane, right? That's why it's 16 by 16, right? But reality, 16 by 16 for us is quite small, and our cube in this reality is quite much larger than our plane, right? Because our cube is big, right? Yes. Let's see. Let's go back to the rotation again. I want to go back. That's why I took it off. So let's go back and put this rotation back for a second. And so I've added this plan, and it says on the x-axis minus 0.5. Okay, let's see if that's the. If I was going to transpile, hopefully copy this now. Finally, right, and go back to incognito mode. Paste it in. Yeah, right? There's that 0.5. I put the 0.5 back, right? That's more accurate, right, isn't it? This is more of the same size. Hey, let me take that 0.5 again off. I just want to make sure that that's not the issue, right? Because somehow we looked at it and it was okay, and now it's kind of weird. All right, so let's go back. I'm doing this so that way you build in Blender, as an example, you kind of visualize in some other program, but you code here, right? Because you want to code by hand. This just helps you out a little bit visualization-wise, right? By the way, there's another piece of code, another program you can use too. There's actually an editor for 3JS. I don't recommend, I'll tell you that. I'll talk about that in a bit too. So let's take a look at this again, going back. So I'm going back here. and 16, 16, 1. Just take that thing off again. It's why is that x at minus 0.5 radians? What does that do? Right? 'Cause remember, I am looking at the thing properly, so you know this shouldn't be an issue. My plane shouldn't have to rotate across the x-axis at all, right? So save it, and then transpile. So that's always good to transpile. Then go back here and refresh. It's gone again. How come it's gone? Darn it. Huh? No. What side am I looking at? How come I'm looking at the back side of it? Why am I looking at the back side and not the front side? And why do I have to rotate by minus 0.5? What's that? Why is that number the number? Right? Because if you take half a percent, so right now I'm looking at it like this. The plane's up like this. You can't see it, but if on the plane, if this is the grid, right? My plane by default, we're thinking that the plane is going to be flat, like it is in Blender, but not so. In Blender, when we make our plane, it becomes like this. That's the default. But what's the y and the x? It's going to go across the x and y. X and y is y up, which means it's in front of us. We can see it, but it's on the other side. Right? And that's why we flip it around, we put it on the x-axis. Because when we rotate minus 0.5 multiplied by math.pi, radians is 90 degrees, right? So we're actually rotating it down flat. And that's why we have to do that, right? It's just math for us, just FYI, so you guys know. So I'm going to put it back. Okay, cool, and we've transpiled. I want to get my cube back in there, and I want to kill some of this other stuff, because I don't care about modifying my cube and cloning my cube. By the way, if I was to run it the way it is, and I've transpiled, just refresh. There it is. Notice how I have a clone feature where I can clone an option. I can clone a, kind of a face here. And I have my actual, if I click on my vertices, I've set up my thing so I can stretch my vertices around and play around with stuff just for your viewing pleasure. And it actually redoes the, everything from the shadows to stuff. And I can look at different vertices to do that. Right, so this is what this code does. We're going to look at how we do that, but I don't need it right now like this. So let's get rid of all that stuff and clean it up. So all we have is a little cube, right? Because I want to try and help you make your assignment 1. That's why I'm doing it, right? So I never asked for any of this stuff, right? So let's get rid of it. So let's go back to code. So we'll go back to code, and we'll take a short break in a second. Well, I don't need this initialize custom mesh. Let's get rid of this. This is underneath Spotlight. So on line 89. If you're following along with me, I'm just going to actually clean this up for 1 second. Take away some spaces. So around line 89, I'm going to get rid of this call the custom mesh function. I'm just going to kill this. Get rid of this. And I'm also going to get rid of, under the controls, here's my controls. I'm going to get rid of my add control points. Just get rid of that for a second. Cool. And I'm going to leave my stats object there and my loop, my game loop, my add event listener for my resizing. But I'm going to get rid of this function, initialize custom mesh. I don't need it for my example today. So I'm going to get rid of all this. Add control points. I'm going to get rid of all this stuff and my create custom mesh. Whoa. So I've just gotten rid of a bunch of code. I'm just going to press delete. So I go right from the end of my init function right into resize. There is no more of that function. I do have an add control function that I'm going to mess around with. I'm going to change this up. But for now, I'm just going to wipe it out. So I'm just going to do one of these. Actually, I'll leave my control object clone in there. Just going to do one of these. Okay, and that's one change. The other change I'm going to make is in my scripts under my objects. Remember how we did a module in TypeScript? I talked about modules in TypeScript. In TypeScript, if I look at my control.ts file, it's actually a module. And I've created a new namespace called objects, right? So this is how you would make a module. You name you kind of surround it with a name with curly braces. So I've named my module objects, right? So step 1, we do this. And this is the containing braces. And then I use the export keyword to export anything I want, a class, a function, a variable, constant, whatever I want to export has to be, I have to use the export keyword. If I don't use the export keyword, it will not be exposed outside of my namespace. So if I made my namespace called objects and I want my control class to be exposed, I need to use the export keyword. Okay, cool. So I want to keep my control class, but I want to wipe it out. I want to just kind of make it empty so we can put whatever we want in there. So for now, just kill all this stuff inside my control class. It's not going to do anything. If you instantiate the control class, you're going to get nothing. And I'll kill my clone method because I don't need that clone method anymore. And that's what it should look like right now. And I'll transpile. So my control class is empty. I'm always going to mess with my control class so that my controls will reflect what I'm doing here. It's the one class that I mess with a lot. Okay? I also added some other ones, game object and point. I'm not going to touch those. They're similar to this one. So for example, point is also in the objects namespace, and I'm exporting the point class if I need to use it. But I'm not going to mess with it. It's just an example of a module. This is how you would write a module. And by the way, this is only one piece. So this is piece 1. And the second piece is on my index.html. I have to include the module here in my scripts. Because remember, my index.html is a manifest that ties everything together. If I don't tie it into my index.html file, it doesn't matter how much I reference it, it won't work. This is the way we reference all the modules in 3JS, Create.js, AngularJS, name it JS, whatever it is, your name JS, right? That's how we reference it, all through the index.html file. Well, other than Node.js. Node.js, we don't need to do it this way. Okay, but that's how we would do it. So first I include my library section. These are all my libraries, my 3JS, my DAC GUI, my stats object, and then my custom scripts. These are my custom scripts I've written. So a point script, a control script, a game object script, and now, of course, my game.ts, my main game.ts script, right? So I need all those pieces. That's part 2. You write your module in a separate file, creates a namespace with the module keyword and the export keyword to expose. We have to include it in our index.html. That's second piece. Third piece, in our typings, under the core module, I have something called a reference TS file. Notice that I included a reference path to these custom objects that I created, game object, control, point. I've added them in there so they're referenced, so that when I reference my reference file, I've got a reference to all those modules inside my game.ts file. So here's my game.ts file, and at the very top, I have my reference path to the reference TS file. If I don't do these steps, one of them, right, module won't work. So it's like there's 3 ways to link a module. You make a module, you link it to your index.html, and then you reference it here somewhere in your code. Right? Those are the 3 steps. And by the way, if you look at typescriptlang.org, it tells you to do that, right? So I'm just following the methodologies right from the website. Okay, cool. 2, yeah, so 3, thank you very much for that. So the triple / instead of the double /, they're still ignored by the compiler, but in terms of code, but the triple / is used as a reference that links the compile. When we build and compile everything, it links everything together to know how the whole one big, because at the end of the day, it's one big document, right? When everything links together in your index.html, it becomes one big, huge document, right? For the browser. For us, it's a bunch of little documents, so we can manage them. But for the browser, it's one big document. So the reference paths helps the browser piece everything together. That's what it does. So we modularize, so when we make a larger scale application, we can manage it, right? And we can scale it up. I can create my objects, right? And then we compile everything together later on for it to work. Okay, so this is what we've done here with our reference path, right? And notice how I have my new control, but it's my old control asks for a custom mesh object, which we're going to get rid of. We can't, that's not necessary for that. And we don't need, see all these custom mesh objects on lines 48, 49, and 50. We can get rid of all that because we're not making those, or faces or vertices. Get rid of all those. So basically, we're left with a more slimmer version of our code. I want to add a cube. I want to add a cube to the scene, and I want to make it the same size as Blender. So if we look at Blender, here's Blender. Right, my cube is buried inside my scene, and the position of the cube in the scene in the cube in the scene, sorry, is at it's 111, but the position is at exactly the 000 point. Now remember, for Blender, all sizes of the cubes when you start off are 2 by 2 by 2 units, right? So if I want to move my cube so it sits on the plane, right? The way I have to do it is I have to raise it up by 1 unit. So I'm going to go across up on the z-axis, my location, by 1 unit. If I go 1, press enter, it raises up, so it sits on top of the plane. Z and Y are reversed, which means my cube is going to be 0, 0 for position, and then and this will be the Z and the Y will be reversed. Okay. Other than that, everything remains the same. My dimensions are 2 by 2, 2 by 2 by 2. If I want the same picture, just to look up here, right? So let's take a look. So how do I make that? If I'm going to use the cube geometry, I'm not going to use my own game object for a second. So I'm going to go here. I've got my spotlight and my ambient. We're going to fix my spotlight, by the way. So we don't have a spotlight on my scene. I'll put that back in. So before my UI controls, which I don't have any use for right now. They're just there as a placeholder for me, right? They don't do anything for now. I'm going to add in a cube just below or just around the place where I've added in my plane. So I've got my plane, and then underneath I'm going to try and I kind of put all my game objects on my scene together so I can see them. So let's just make some room, and underneath my plane I'm going to say add. Let's try this together, guys. Add a cube. Scene. Okay, so I want to add my cube. Remember, it's 2 by 2, 2 by 2 by 2 actually, and that's 1. And the second thing is it's 1 up from the plane. All right, that's what I got to do. So how do I do that? First of all, what are the 2 things I need for all primitives? Right, I want to ask you this question on Wednesday. What are the 2 things I need that make up a mesh? Right, for all primitive meshes, there's 2 components that geometry and material, those 2 things, right? So I'm going to need those 2 things for my cube mesh, right? So notice up here, I want to make this kind of, for our purposes, a global object. And I do. I have a cube stand-in, a variable that I've kind of created as a stand-in object called cube, which is a mesh, right? I also have up here, I've kind of created some aliases for cube geometry and Lambert material, which is what I'm going to use. But I need to create some material variables and geometry variables. So I'm going to do a var, and I'm going to make a cube geometry lowercase, which is of type cube geometry uppercase, because it's just an alias, right? So I'm kind of typing this out, right? Like typing means like I'm creating a type for the cube geometry I'm going to use, and I'm also making a variable, a container on the global namespace. Okay, same thing with my cube material. It's going to be a Lambert mesh, right? So Lambert material is what I'm going to use for my cube material. There it is. So those 2 things I've added. Now that I've added those 2 variables, I can use them, right? So the first, it doesn't matter which one you choose, geometry or material. Let's just do one. So I'm going to say cube material, right? Cube material is equal to a new Lambert material. Lambert is just one type of material. And notice from a parameters perspective, it's listening for what? An object, right? And the object has to be put in curly braces like this. All I need to do right now is make it a color. I don't need to have any other material, or any other aspect of my material or property. So let's make it, we'll say color, and let's make the color green. Like, how do I make green? Well, it's pound, right? RGB. So red, 0, 0, green, right? FF, B, 0, 0, right? And that's how it would be, right? So RGB. But notice instead of the pound, we wouldn't do that. We put the 0x. 0x is the hexadecimal way we do things in 3JS, right? And that's how it would look. Notice here's an example of that up here, right? So 0x. So telling our compiler that it's hexadecimal, and then 00FF00, so RG, very green, B, right? Okay, that's our cube material. Now let's talk about our cube geometry, right? This is where we do our geometry, which is, again, a new object, new, capital C cube geometry. And if I open it up, ask for, at the minimum, a width, a height, and a depth, which is 2. That's what we decided to do. So 2 by 2 by 2, right? That's what we said for cube geometry. Okay, cool. Now we want to make a new cube mesh. So we're going to say cube is equal to a new mesh object where we're going to pass in the geometry So cube geometry. And the material, cube material. And we've added those in, right? But it doesn't mean that it actually will show anything. And the reason why is because I have to do one more step. I have to add it to the scene, right? So I have to do, down here, I have to at least put something like this. Scene dot add, and then cube. If I don't do this, then it's not going to be shown, right? The other thing I want to do is it has to receive and cast shadows, right? I want it to receive shadows and I want it to cast shadows, right? So I have to say cube dot, cast shadow, right? Notice that it's a property, so I just say is equal to true. And cube dot receive shadow, if I can spell everything properly, that's also equal to true. So I want it to kind of receive and cast shadows. Otherwise, it will not cast shadows and receive shadows. If I don't want it to receive or cast shadows, I can turn that off, right? If I want to make some other kind of drawing, whatever. Okay, cool. And then I'm going to use a simple console command. This is just me. You don't have to do this. Console command that says added, cube, primitive to scene. There you go. Oops. If I've done everything correctly, my cube should be in the right position. Oh man, I forgot one thing. It's got to be up one, right? Because otherwise it's going to be halfway into the plane if it's like blended, right? So I can say, well, cube dot position, and what is it if I want to go up one? Y, right, is equal to 1, right? Because I want to go 1 up on the Y plane, which is up and down in our scene, right? Remember, we're Y up. Okay, so those are the things I want to do. And let's transpile. Now we're still going to have issues. And we have some 6 errors, it says. Let's take a look where it says where our 6 errors come from. Here's our 6 errors. It says, cannot find named vertices on game.ts. And it's looking for it under here, right, in our game loop. That's a big problem, right? So let's clean up our game loop so I don't have any of this vertices stuff. This is under around line 134 in my program here. Cool, save. I've got rid of all that. Now no errors, and then transpile. And then I'll upload it to GitHub so you guys can see what I have, and you can have what I have. Okay, so here it is. Let's take a look and see what I've got now in my code. So this should disappear. Should be very much simpler. I should have a cube that's 2 by 2, 1 up. It should be green, and it should be solid. Let's see if I did everything correctly. I may have not, right? And you can see how, even with incognito mode, it's just locked up. Okay, so let's just try that's how it works, guys. I'm sorry to say. Oh yeah. This might be a great place to stop. Yeah. Does it do any error checking for me when I do TypeScript from command line? No. Well, it would if you had the right version of TypeScript. Yeah, so it looks like I'm locked up. So this is a great place to stop and take a short break. So let's go and let's take a 5 or 10 minute break. When I come back, I'll continue with this example. Luckily, I saved everything. But like I'm locked, like locked. Which means I really may even need a reboot. Woo! Right? Let's try this out. So for those people, if I'm still recording, then I'm going to stop recording now, and I'll come back. When I come back, I'll have everything going. Oh, that was good. Rats, WebGL had a snag. Okay, so it killed me. Let's see if I'm still recording.